In this video, I will show only the Python implementation of linear regression, logistic regression, and neural networks. So let's start with linear regression, and we will do it on a very dummy data. So first we will import this NumPy as usual. The next package we need to import libraries from is actually sklearn. So you should remember that sklearn is a broad package which contains all the major machine learning algorithms. But in particular within sklearn, we have to import libraries for linear regression. So there is a subset of sklearn which is called a linear model. So from sklearn dot linear model, now we need to import linear regression. Okay, now we need to first provide the input. We will provide a very simple dummy input. Let's say we have this input. So what does it mean? So it means we just have a very simple input of 2 dimensions, and that is what we are here doing. So the first entry is the input is having 2 values. I mean the first dimension f1 and 1, second dimension, then the next entry 1 2, so then 2 2 2 3. So if you see from the dataset terminology, so this will be x1 and x2, basically x1 x2 x1 x2 x1 x2, and you know the first entry of data 1 is x1 subscript 1, x1 subscript 2, this 2 will be x1 subscript 3, so on and so forth. So this is a simple 2-dimensional input vector. We can say the feature vector has dimension 2. There are only 2 features at the input, so this we will provide as an input. Now here I am writing as a comment the dummy relationship which I have myself created. So I am assuming that suppose somehow I know the actual relation between input and output, that is y is equal to 1 times x1 plus 2 times x2 plus 3. So then I personally know all the values. So this is theta 1, this is theta 2, and this will be theta 0, right? So this relationship I am already knowing. It's like something I am knowing, and like now I am telling you to predict. So this is the comment. By the way, this hash sign works as a comment in Python. It is not being implemented. Now to implement this line, I will write this line. See, what is this? If you remember, y is actually equal to theta transpose x. Now theta transpose x is actually dot product. So I'm writing np dot dot dot. This actually means dot product. And in linear algebra, dot product between 2 vectors, suppose x and y or a and b, is done using a transpose b, x transpose y. So this x is actually the input features, and the I since know the theta beforehand, so 1 and 2. So I'm actually creating the output. So this theta is here np dot array 1 2. So this is basically that theta vector, and then plus 3 because I need to add this theta naught, so plus 3. Fine. So this is one way, or another way is if you want to take that bias element as x0, then you can define that in x itself, but this is fine. So now I've run it. So this is actually the output. Okay, so this is all I am doing, a dummy thing, so as to verify perfectly and to demonstrate linear regression is working. I am generating output myself from a relationship which now I will predict using linear regression. So this is something like really dummy thing. In practice, what you will have a data set. You will not have the relationship, rather you will assume that the relationship is linear and derive the weights. Now we have already included this linear regression classes from the sklearn package. Now if you write it linear regression and press dot, you will see a lot of functions which are provided here. So one of them is fit. See, what are we going to do? We have the data set available with us. See, this is the input x and this is the output y. We want to fit it on the linear model. so that we get the weights. Although the way we have generated the y, in one sense we already know weights, so this will help us to verify whether linear regression will be able to predict the weights exactly or not. So linear regression, then we write like this, two brackets dot, there is one subclass, there's one function fit xy, and then run it. Okay, so what basically this does is it fits the data over the linear model and tries to get the model parameters. Now we would like to save this in some object, so let's call it regress. Regress is equal to linear regression dot fit xy. Now we have this regress object. Let's see what it contains. Dot tab. You see there are a lot of parameters here, lot of some sub functions and some parameters, and let's try to see the coefficient one. Okay, dot coefficient. See what we got. Regress dot coefficient. These coefficients are actually the weights here, and you see it provides output 1 and 2, which is already what we have. If you recall again here, what we did, we first imported numpy, then we imported sklearn dot linear model. From that we imported linear regression. Okay, then we created the dummy input ourselves, 2-dimensional, and then we first generated output by assuming a linear model ourselves. So it is like this. I am creating a linear model, I know the weights, I just provide you input output, and I tell you that use linear regression to generate the weights. Then I will verify, okay, yes, you have got exactly same answer, so you have successfully run the linear regression. This is what we are doing here. So basically we are now using this relationship y is equal to 1 plus x1 plus 2 plus x2 plus this x x naught or 3. So this theta 1 is 1, theta 2 is 2, and this is of course theta 0 is always 1. Now this already we know. Then what we did, we wrote linear regression, then 2 brackets dot fit. So this is a sub function within this object. What it does, it fits the data input output over the linear model, the linear regression model. Then regress dot coefficient gives the coefficient, and we can have other functions also. Let's see what are the other functions which we can use, or other parameters rather. Suppose there is this intercept. In linear, in the case of straight line, the intercept means where the y-axis is cut. So here the intercept means that theta naught, which is also called bias. So let's run it. Sorry, I selected the wrong things. It's actually regress dot intercept underscore. Yes. So this provides you the value. See, it is 3. Now you can see it is 3.00000018. Definitely there will be some error, because inside the algorithm, which is called gradient descent, is running for finite time, so you will not be able to get always the exact answer. But we know that if you go back, we know that when we ourselves generated output from the non-linear model, so we added 3 here. So 3 is the intercept, and this is, we are getting it 3 here itself. Okay, there is one more thing called score, which we have not defined it. Sorry, it is regress dot score. So you provide the input and output values, and let's see the score comes 1. So this score is actually some sort of a metric to see how accurate our model is. Since we have generated input output ourselves from a linear model, we are getting almost 100%. Score 1 is the maximum value you can get. If you get score less, then it means the prediction is not accurate, the linear model is not good. Now I will show you one example of logistic regression, and with that we'll learn some more couple of things in Python. So let's first come to packages. Since we will need here pandas also, so I will show how to create a data frame. So import pandas as pd. This is one package. Now to invoke logistic regression, will same from sklearn dot same linear model, then import logistic regression. Okay, and then you can see logistic regression, if you say dot, then you will be able to see all the same type of parameters it has as within the regression. Now let's first think about data. So I have taken this data from some simple online source, and let me first enter it. So what is this data about? So this data has basically three, we can say three things: two input and one output. One is the age, gender, and then whether the person with particular age and gender is smoker or not. If it is smoker, we denote that by 1. If not smoker, then by 0. And we want to basically get a logistic regression based model, so that if we tell someone's age and gender, it should be able to tell us whether he or she is smoker or not. A very dummy example, will be completely incorrect also, but this is based on some data we have generated just like that. Now this data here, you see I have typed here this type data. It gives you what type of data type is this. So there comes DICT. It's called dictionary data type. So dictionary data type in Python means we will have data with some key, like age is the key, gender is the key, and smoker is the key. So it means that in one sense you can think of key as like a column. So this is all age category. So dictionary data type is just like you can think of it creates 3 columns: age, gender, and smoker. And in dictionary data type you can have mixed type of data, like you can see age is numbers, gender is string, and smoke is a binary data. So this way you can create dictionary data like this. Very easy. Just name it data, then brace start, then in single quote define one data type with the key age, then second data type with key gender, and this combined it is called dictionary. Now if we want to create something called a data frame, which is the fundamental data type in pandas, how to do that? So we will write here data frame. Since we have already invoked the pandas, so okay, sorry, I think pd.dataframe, yeah, pd.dataframe, and then which data you want to convert in data frame. I want to convert this data data into data frame, and then after converting it into data frame, save it in df. Okay, now you see this is the data frame. If you remember in our previous lecture of pandas package, we imported the CSV file, Excel file, and that was saved as data frame. In this case we had a data type, separate data type called dictionary data like this. We convert this into data frame. Now data frame has some elements. One is these 3 are now as a columns: age, gender, and smoker. Age and gender are input, x1, x2. We can say smoker is the output. Whether smoker or not is output, y is equal to 1 or 0. And this data frame has this 0, 1, 2, 3. This is like you have an arrays in C language also. You start with 0. You are basically having this as an indicator which row we are in. Now the first to learn new thing here is this. See, we have studied logistic regression where the input is numerical, and this is one of the cases where we will learn how to convert this non-numerical data into numerical data. See, the gender here is male, female. You cannot provide this as the input. Input should be some number or a binary instance. Now instead of having, we will convert this input into different form. So what we will do is like this: age, then we can ask two questions, one of them. So we can either create a column which asks whether the gender is male, then we will enter true, false, or whether the gender is female. Let's see like this. Okay, so let's select male. So we will like to have age, then second column as is this person male, then we will enter true, false. True, false is a logical data which is acceptable, which internally is taken as 1, 0, of course, again, and then the output smoker is fine. So now how to do that using pandas? For this purpose, pandas has a function which is called get dummies. get dummies is a function which will take any data type which has a potential to get converted into logical data type, like this gender, male, female. We can write it in such a way that it decide so convert this into a categorical or indicator type of data type, where instead of saying gender is male or female, we'll ask whether the person is male or female, whether the person is male or not, like this. If it is male, then it will be true. If female, then it will be converted into false. So first we need to provide which data frame. So we call the df. Df is the data frame we have, and then we need to provide him information about which column we want to convert into this data type. So column is equal to this gender, and then there is one important instruction. Okay, before adding that parameter, let's run it like this. Let's run directly. Yeah, the only correction I need to do is when I had to add a column, so it should be like this. So column is like this. Okay, let's see. Okay, wait, what happened? column. Sorry, I had to use columns because by default it can be more than one. Fine. Now let's run this function pd dot get dummies, then df is the data frame, and c columns is equal to gender. You see what it provided us. It provided the column age, the column smoker, and then it converted that gender into two columns, or we can say two sub data types. One, whether gender is female or gender is male. See, one of them is sufficient for us, because if we know that a particular person is not female, then definitely it has to be male. So we want to drop this first one. We want to drop one column because only one is sufficient. So there is one important instruction we can add here. So we write here drop first is equal to true. That is, drop the first column. You see, it dropped this gender female and it only provided gender male. Now this is sufficient input for us. The input is age and gender male, and the output will be whether the person is smoker or not. Now what is the next step? We need to take out the input separately. So df dummies, then to extract specific columns, so we have to first long bracket, then next long bracket is about mentioning the columns. So as part of input we need age and gender male. So this one, third part, so gender male. Okay, what is the name? Oh, we haven't saved, sorry. So we have created data frame here, but we had to first save it. So let's run it again. So pd will define here pd dot get dummies, whatever gets here is as df dummies. Okay, fine. Now this command will be run. Okay, so this is the data frame which only contains now the input. We'd like to save this is in some vector x. So now x contains only the input, age and gender information, and we would like to now store in y df dummies. And what is the output? Output is here smoker. Okay, so this is the output now. Now we have this logistic regression, and we can say logistic regression dot fit, give the x and y. Okay, but we need to save it this object in somewhere. So I will write here logit regress. Okay, same as linear regression. Now this logit regress, logit regress is the object. You see it contains all those and parameters like we had in linear regression and some more. Suppose if you have here coefficients, so these are actually the two coefficients or the weights associated with input. So the first input we have provided is age and second one gender. So for age the theta is this value and for gender theta is having this value. Okay, now before we proceed, we will do something which we call as dividing the data set into training and testing. So this time what we have done, whatever data we had, we treated this as the training data. But how to test the model? So what we will do is we will divide this into training and testing. Although the size of data set here is very less, but same will apply to the data sets which are very large data sets. So let's see how to divide. For that, you have within sklearn a subclass called model selection. So from sklearn dot model selection import train test split. So this will contain the functions which will split the data set, and it does not split it linearly. That is, suppose you have here the input output. Now it is not like okay, let me take the data set first. So this is our complete data set. Age and this gender male is the input, smoker is the output. Okay, so splitting does not mean we will take first 5 samples as training data set, next 5 as test. No, that will not be good choice. We need to randomize. So it will randomize basically all the data entries. It will choose first, maybe then third, then sixth, then 10th as training samples and then rest of them as testing samples. It basically does randomization inside the function. So now let's concentrate on what function we need to run to split data into training and testing. First we decide about the variable names. So we have 4 variables here. One is xtrain, that is the input of training samples. Xtest, this is the input of testing samples. Then ytrain, the output of training samples. Ytest, the output of testing samples. This is equal to, then we have a function which we call as train test split. Then we will provide the overall data set as input, that is here x comma y, and then we need to decide how what percentage of the data set is to be used as training data set and what percentage as testing data set. Suppose we write here test size is equal to 0.3. It means 30% of the samples will be used for testing, 70% of the samples will be used for training. Okay, so we'll run it, and now see we have x train. It has chosen randomly. You see the randomization 8 6 0 3 4 9 2. Similarly x test, it has chosen randomly these samples. Similarly ytrain, it has chosen these outputs correspondingly. Now we will again call logistic regression, then fit, but now we will not give xy, rather we will give x train comma y train as the input. Okay, sorry, there's a typo here, x underscore train. Okay, so now we will store it in some variable. Let's say regress logit. I will write this name. So regress logit dot, see it has now all these parameters. Suppose you need to know the coefficients, so it will give the coefficient. These are the values of the weights. Now see the weights are now different values because our data set has now changed. Our training samples are different than what we had earlier. Now suppose we want to predict the output, so we'll give x test, the test sample input. So we have here the predict. Okay, so this we will pass on the input. So we will run this regress logit dot predict, and input we will give is x test, the testing samples. So we do that. What we got is we store those values in y predict. Now it returned 3 values 0 0 0. It means that where the testing sample is, so here, so for these 3 test samples with age 50, 30 and 60, and all of them are females. Okay, so it is given that they are not smokers, so that is the output here. But let's check it from the original data set. Okay, so what is this? What is the label? The label here is let me check the label. So in testing data set, the label is here 517. So let's check it in the original data set. 5, okay, is not is female. Oh, come to this point. Yeah, 5. Okay, according to this, 5 is smoking. So it means that there is an error. So because the data set size is very small, so there will be error. So 5, 1 and 7. Let's check 1 and 7. 1 and 7. 1 and 7. So it has made errors here in all the 3. So because of small size of the data set, it is quite possible that there will be errors. And also it depends upon what samples you choose. If you see, all the 3 testing samples have been chosen same. This happens when the size of data set is small. But when the size of data set is realizable, suppose 10,000 points are there, then when you choose 30% for testing and 70% for training, then the variety of samples increases. Because we have here small data set, we will not be able to see. So here all the 3 decisions made are not correct in this case. So the video is already more than 20 minutes. So I will now make a part 2 of this where I will record the neural network video, how to make a simple neural network in Python and make classification based on that. Thank you.